Looking at homework, page 206, 1 through 5. So for number 1, there is a car that's 1,500 kilograms. It is traveling at 15 meters per second. It runs into a truck traveling at 4,500 kilograms, traveling 0 meters per second because it's at rest. What is the final velocity of the combined mass of cars? To do this problem, we need to use some equations. And you can see here the equation that we have, where our two masses that have their own individual momentum, so this would be the car, this would be the truck, they run into each other and both travel together. So V final of both added up together. And so we're going to take this over here and that over here, like thus. And now I'm going to put in a little bit of math. So I've got to put in a plus, plus and equals, and a plus right there, like so. So when you go to solve it, we can see that this here is going to be, 0 kilogram meters per second right there. Here we've got 1,500 times 15. That's 22,500. 22,500 kilogram meters per second. And that equals over here 6,000 kilograms times VF. And then we need to solve. And to solve that, we're going to divide by 6,000, and 22,500 divided by 6,000. And the velocity of the combined mass comes out to be 3.75 meters per second. And when you're comprehend checking this, you gotta think to yourself, alright, smaller car with some speed hits bigger car with no speed. Together, does it make sense that they're going to go kind of slow? Yeah, comparatively they're going to go kind of slow when those two are stuck together. You got a big old car there, big old truck. Alright, let's look at number 2. And now we're on number 2. We've got a bag of groceries. What is it? A bag of rice traveling at 5.5 meters per second. It's thrown into a shopping cart that is stationary. Then the bag and the cart move along together. So we need to multiply 9 times the 5.5. So what's going to happen is the momentum of the bag of rice plus the momentum of the cart will equal the momentum of both of them together. And when you take 9 times 5.5, you get 49.5. And of course you're adding that to 0. And then 9 plus 18 is 27. And so then you got it set up like this, where you got the grocery cart has 0 momentum, this is this, then you need to divide by the 27. Divided by 27. And you see that it comes out to be moving in a whopping big 1.833 meters per second. Alright, now let's move on to number 3. So now in number 3, we've got 2 train cars sticking together, and they give us the mass of 15,000 kilograms. And the first one's going 7 meters per second. It runs into an identical car going the same direction at 1.5 meters per second. That's important that it's the same direction. Otherwise, you have to put a negative in. And then we want to know, when they click together and stick together, how fast are we going together? So we got to take 15,000 times 7. 15,000 times 7. That's 105,000. 105,000. And then we have one going 1.5 meters per second, so 15,000 times 1.5. and that's 22,500. 22,500. And then that's going to run into a combination here of 2 train cars, 30,000. And then we have to add these up. So 105,000 plus 22,500 is going to give us 127,500. $127,500 over here on this side of the equation equals 30,000 VF, and then we're going to divide by 30,000. So divided by 30,000. We'll divide by 30,000 and get a very small number that I did incorrectly something. Alright, try again. 127,500 divided by 30,000 comes out to 4.25 meters per second. I had typed the wrong thing in the calculator, that's why I had to hit pause there, guys. So that is number 3. And then on to number 4. Alright, looking at number 4, this one's set up a little bit different. We have a dry cleaning bag here. It's thrown into a stationary cart, but we don't know how fast it's thrown. But we know that the cart and the bag together go off at 3 meters per second. So what you want to do here is find this velocity when we know that that momentum is 0. So add up the cart and the bag together and you get 31 kilograms. And you're going to multiply that by the 3 meters per second. And together that comes out to 93 kilogram meters per second. Comes out to 93 kilogram meters per second. And then we know that the momentum of this cart was 0. And then we know that the velocity is unknown with the 22 kilograms. So we're going to divide by the 22 kilograms. Divided by 22. And it comes out to be 4.2 meters per second. On to number 5. So for number 5, when you're reading through the problem here, you've got a skateboarder, so a person, would be mass 1, 47.4 kilograms, and they're running down the sidewalk with a speed of 4.2 meters per second. So you can get the momentum of the kid here. Plus, there's a skateboard here. It's not moving. It's a stationary skateboard, and so therefore the momentum here is 0. And then the kid jumps on the skateboard and they go off together. So the only thing you don't know is m2. So you're going to have to then distribute the velocity to both. You're going to have to subtract that over and then divide by the velocity to get that mass alone. And I really like to show that one on the board in person instead of trying to do it here artificially. But that's the only variable really is the mass 2 on the final side of the problem. The initial mass kind of goes away because the skateboard is stationary and the initial momentum is 0. So you're just solving for mass 2, the skateboard. And then on the next page, I had to do number 2. And number 2 is talking about how the energy is not conserved in the inelastic collision. And so for part A, you're taking a ball and kicking it into a bucket and finding the velocity of the bucket and the ball together. It's just the same inelastic collision where you've got the ball, the bucket, and then the ball and the bucket are together. And so you find that velocity. Then it says find the decrease in kinetic energy. Well, the bucket is initially stationary, so it does not have kinetic energy to worry about. But then you just use the kinetic energy equation, 1/2 mv squared, with the mass of the ball and the velocity of the ball. And then you calculate over here with the mass of the bucket and the ball and the combined velocity. And there's going to be a drop in energy, and that's what we want to find, is how much less energy do we have.